Hi guys. So the good news is, as I'm sure you can already tell from the little heading of these notes, we're finally done with chapter 7 involving factoring. But unfortunately, as I think you can also tell, we're not completely out of the woodwork yet with factoring. We've still got a little bit more to do with it before we move on to something else, even though this stuff does come from a different chapter. I do just want to refresh factoring real quick because obviously it is going to come up in today's lesson. Just real quick practice for how to factor. All right. Both of these polynomials, they're trinomials. They have the leading coefficient other than 1. So all we're thinking about for both of them is factors of that last term that add up to the middle term. Oops. So we're looking for factors of 35 that add up to 12. So what are factors of 35 in this case? We've got 1 and 35. We're looking for factors of positive 35, so we could make them both negative. 5 and 7. And is 35 divisible by 3? I don't think so. No, so I think that's actually going to be it for factors of 35. Which one of these options adds up to positive 12? Positive 5 and positive 7. So the way this first one would factor down is x plus 5 and x plus 7. Okay? Factors of negative 63. Now in this case, because of the negative, one's got to be positive and the other one's got to be negative. So we could have negative 1 and 63, or switch the signs. We could have negative 7 and 9. Switch the signs. 63 is not going to be divisible by 2, but it is divisible by 3. So we could have negative 3, and that's 21. Or the other way. And that might actually be it. Yeah, I think that's it for factors of 63. So again, which one of these adds up to positive 2? Well, 9 minus 7 is positive 2. So that one right there. X minus 7 and x plus 9. And as I keep saying, the order of the parentheses themselves doesn't matter. You just have to be careful with the signs. I would be looking for negative 7 and positive 9. Okay? So, if anybody still does look in the textbook for anything, this comes from section 8.6. We're talking about solving quadratic equations by factoring. So clearly you're still going to have to know a thing or two about factoring. And basically, the book just goes through and specifies the difference between a quadratic equation. Really, a quadratic equation is nothing too different from a normal equation that you've seen. A quadratic equation is an equation that can be written in standard form, ax squared plus bx plus c equals 0. So we know a quadratic polynomial has its biggest exponent as 2. All right. Most of the time when we have quadratic equations, they are going to be quadratic trinomials. But the big thing that you probably remember from the beginning of the school year and from middle school is that the big difference between a quadratic expression or an expression in general and an equation is the fact that equations have equal signs and expressions don't. So everything that we've been working with up to this point in terms of factoring involves quadratic expressions. And now we are talking about quadratic equations. All right. So most of the time you are going to see your quadratic trinomial equaling 0. And it's really important that you do have it equal 0. Because of this thing called the zero product property. All right, the only other thing this first part talks about is there are multiple names for the solutions to quadratic equations, including solutions, zeros, and roots. All right, these other two are going to come into play more as we do other sections in chapter 8. But we should be familiar with the term solutions. How many solutions are there to an equation or something like that? The one thing I do want to say while I'm on that subject is because you're talking about quadratic equations and your biggest exponent is 2, you should expect, on average, 2 solutions when you solve these kinds of quadratic equations, all right? Most of the time, you're going to get 2 solutions. You will never get more than that. You're never going to get 3 solutions or 4 solutions. You might get 1 solution, or you might get no solution. But the majority of the time, you should expect to get 2 solutions, so 2 different numbers as your final answer, all right? And in order to figure this out, this is, again, back to what I was saying before, this idea of the zero product property. All right, so what does this actually say? Ugh. If the product of 2 quantities equals 0, at least one of the quantities equals 0. So that, I think, leads more so into this algebra idea, all right? If you have 2 variables or 2 expressions that are being multiplied together and the whole product equals 0, then by definition, either one of them must equal 0. But it's not really like a case-by-case basis. This lets you set both of the expressions equal to 0. All right? That's basically the zero product property. So, oh, there's a blank page. Fun. Okay. So, hold on. All right. So here's what I mean by that. All right? We have 2 separate expressions that are being multiplied together and are set equal to 0. So what the zero product property allows you to do is to take these expressions separately and set them both equal to 0. So we can say x minus 7 is equal to 0, and we can also say x plus 2 is equal to 0. And then we can solve both of those equations exactly the same way we have been doing since like September. Add 7 to both sides, so x equals 7. That's the solution to one equation, and that's the solution to that's one solution to your giant thing in the beginning. Minus 2. The other solution is going to be x equals negative 2. Both of those are going to be solutions. But because the question also says check your answer, we will have to plug both of these back into the original. So we're going to do that one at a time. We're going to do 7 first. So 7 minus 7 times 7 plus 2, we want to see if that equals 0. Well, 7 minus 7 is 0, and 7 plus 2 is 9. So 0 times 9 is 0. That one works. Negative 2. Negative 2 minus 7 times negative 2 plus 2. We also want to see if that equals 0. Negative 2 minus 7 is negative 9. Times 0 is also 0. So that also works. So that means we got both values right, and these are both our solutions to our equation from the beginning. Okay? Same thing here. We're going to take the separate expressions in each set of parentheses and set them both equal to 0 separately. X minus 2 equals 0, and x equals 0. Now, the nice thing about this second one is that we already have x completely isolated. X equals 0, so we're actually already done with that. To isolate x here, we do have to do a little bit more work. Add 2. X is 2. And again, we'd have to plug them both back in separately in order to make sure that they both work. 2 minus 2 times 2. Does that equal 0? Well, this is 0, and 0 times 2 is 0. So that one works. And now we're going to do the same thing with 0. So 0 minus 2 times 0, does that equal 0? 0 minus 2 is negative 2 times 0 also is 0. So they both work. Let's see. I think, so this is the same one as the first one, so I think I'm going to hold off on this, but I will do it and post a digital copy of the answer key like I usually do. So all this is saying where the factoring comes in. If a quadratic equation is written in standard form, which we know looks like this, then to solve the equation, you may need to factor before using the zero product property. So that's where the factoring comes into all of this. We don't, here we go. we don't have any expressions in sets of parentheses, all right? But if you kind of go back, hold on a second. If you go back to the problems we did before, these answers or this part of the original question, it kind of looks like the answers we would get after we would factor something, you know? So to get to here, from here, we're going to want to factor first, all right? So for now, we're just going to kind of ignore the equals 0 and then worry about it later. So we're just going to factor x squared minus 6x plus 8 first. And this goes into the same kind of things we were doing in the warm-up. What are factors of 8 that add up to negative 6? So what are factors of 8 first? 1 and 8. Make them negative. 4 and 2. Make them negative. So which one of those pairs adds up to negative 6? This last one. So our parentheses are set up as x minus 4 and x minus 2. And now this is where the equals 0 comes in, because this looks kind of like what we were doing before, all right? Now that we have two sets of parentheses and everything equals 0, we can split these up into two separate equations and set them both equal to 0. So x minus 4 is equal to 0, and x minus 2 is equal to 0. So same thing, add 4. X is going to be 4 for one, and add 2. So x is going to be 2 for the other one. All right? Now the question also says check your answer. So as I hope you guys remember from the very, very beginning of the school year, when you check to make sure that the solutions to your equation are correct, you want to plug it back into the original. All right? So we're going to plug both of these numbers into the original. X squared minus 6x plus 8 equals 0. And we're going to do this one at a time. So we're going to do 4 first. 4 squared minus 6 times 4 plus 8. We want to see if that equals 0. And if you're doing this by hand, we're doing order of operations. All right, you're more than welcome to just plug this whole thing into your calculator as long as you're careful with exponents, your signs, and your parentheses. But let's try to do this by hand. All right, order of operations, PEMDAS. Parentheses first. I mean, there's really nothing in this set of parentheses to simplify, so we'll move on to the exponents. 4 squared is 16. And then we have multiplication and division. So negative 6 times 4 is negative 24 plus 8. And then we're going to do addition and subtraction in order from left to right. So 16 minus 24 is negative 8 plus 8 does equal 0. So 4 is good. And then for 2, 2 squared minus 6 times 2 plus 8 should also be equal to 0. This is 4 minus 8, oh not minus 8, minus 12, sorry, plus 8. 4 minus 12 is negative 8 plus 8, and that also is 0. So we're good on both accounts. Okay? All right. Same idea. We're going to ignore this and just focus on factoring. Factors of 36. 1 and 36. 2 and 18, I think, right? 36 divided by 2 is 18, yep. 3 and 12. 4 and 9. And 6 and 6. So which one of those adds up to negative 12? This one that I wrote on the blue part. Negative 6 and negative 6. All right? So, x minus 6 and x minus 6. That's how that one would factor. Okay? But the nice thing about this specific problem is that, well, you guys hopefully should remember that if you were just factoring this, you would be able to condense x minus 6 times x minus 6 into x minus 6 squared. You don't really need to worry about that here, but what's nice about this is that if you broke this up the same way we did the last problem, x minus 6 equals 0 and x minus 6 equals 0, because it's the exact same polynomial twice, you're going to get the exact same equation twice. So you're going to get the exact same solution twice. So you don't even have to show this work twice. You can just do it once. I'd be totally okay with that. Add 6 to both sides, and x is 6. And this is one of those situations that I was talking about before where you're only going to get one answer because you're just going to get the same answer twice. All right, so this is a situation where your quadratic equation only has one solution. All right? So if we check this one solution by plugging it back into the original, 6 squared minus 12 times 6 plus 36 should be equal to 0. 36 minus, what's 12 times 6? 72. Plus 36 should equal 0. 36 minus 72 is negative 36. Plus 36 does equal 0. So we're good on that. Okay. And I think this one is the same as the last one, so I'm going to hold off on it for now. Okay. This looks like it might be, hold on. These rest of them out of the way. This looks like it might be one of those where you would have to think about factors of 6 and factors of negative 144 or factors of 144. Oops. But don't forget that the first thing you always have to think about when factoring is trying to take out a GCF. So R6, negative 30, and negative 144 are all divisible by the same thing. Yeah, they're all divisible by 6. So if you do that, you're left with 1, negative 5, and 144 divided by 6 is 24. So this is negative 24. There's no variable in common. So your GCF is just 6. And this is x squared minus 5x minus 24 equals 0. And now this is a lot simpler to factor. Okay? What are factors of negative 24? Negative 1 and 24. Switch. Negative 2 and 12. Switch. Negative 3 and 8. Switch. Negative 4 and 6 and switch. All right. So which one of these pairs adds up to negative 5? Again, I think it's this one that is in blue, 3 and negative 8, because 3 minus 8 is negative 5. So I'm going to just move that up here where this is x minus plus 3, sorry, and x minus 8. Don't forget about that GCF, and it equals 0. Now, the difference here is that now we have 3 pieces of it, all right? 2 binomials and 1 GCF. So we do have to at least try to set all of these, all 3 equal to 0. 6 equals 0, x plus 3 equals 0, and x minus 8 equals 0. These two we know how to work with. Minus 3, so x is negative 3, plus 8, x is 8. But what happens with the GCF? Is there ever a situation where 6 is equal to 0? No, not possible. So taking out the GCF in this case honestly just made our lives a whole lot easier in terms of factoring. But beyond that, there's really nothing else we can do with it in terms of the actual solving. So our 2 solutions are just negative 3 and positive 8. All right? And same kind of thing, we have to plug these both back into the original to see that they both work. 6 times negative 3 squared minus 30 times negative 3 minus 144 equals 0. Negative 3 squared is 9 times 6 is 54 plus 90 minus 144 equals 0. Use your calculator for all this. All right? Order of operations, exponents first. Negative times a negative is a positive. So 54 plus 90 is 144. Minus 144 does get us 0. Cool. And now we're going to do the same thing with 8. 6 times 8 squared minus 30 times 8 minus 144 should also equal 0. 8 squared is 64 times 6 is 384 minus this is 240 minus 144. I think that all works. What was it? 384 minus 240 minus 144. Yep. That's 0. Cool. Okay, so that's the check part. Again, these are our answers. Okay. Okay. This one, because of that one, there's definitely not going to be a GCF. All right, so this is going to be one of those where you will have to think about factors of 3 and factors of 1. Luckily, it's pretty easy. The only factors of 3 are 1 and 3, and the only factors of 1 are 1 and 1. So there's really not many possibilities here. We have x and 3x, and then we have 1 and 1. And then it's just a matter of worrying about our signs. 1 times 3x is 3x. X times 1 is just x. How can we make negative 4? We'd be able to do that if both of them were negative. And if we double check that the factoring is right, negative 1 times negative 1 does get us that positive 1 from the original. So the factoring is good, but we're not done with the question yet because we still have to solve it. All right, and we can use the exact same zero product property by splitting them up and setting them both equal to 0. So again, I'm going to do that over here. X minus 1 equals 0, and 3x minus 1 equals 0. This is easy. And this, again, this should still be easy considering we've done it since the beginning of the year. It's just a little bit more work. You would add 1. So 3x equals 1, and then you would have to divide both sides by 3. So in situations like this, yes, x does equal 1/3. You might get some fractions for situations like this. Mostly if you have to deal with a leading coefficient that's not 1. That's really the only time you should expect to get fractions. But if you do get fractions, that is absolutely fine. All right? Because of that, though, checking your answer is probably going to be a big mess. You would be able to do it, though. Everybody should have calculators by this point. So this is over 20 minutes. So I'm just going to show you how you would do this with 1/3. And then I think we're going to move on. You would still plug it all in. 3 times 1/3 squared minus 4 times 1/3 plus 1 is equal to 0. So this is where the calculator comes in. All right. This n over d is the fraction button. So if you do parentheses, and you need to do parentheses, 1 over 3, close parentheses, squared. That's what 1/3 squared is, times 3 is 3 over 9. And this arrow means that you can simplify it. So if you hit the simplify button over and over until the arrow is gone, this is what you're left with. All right, so this whole first term simplified is 1/3. And negative 4 times 1/3, negative 4 times fraction button again, 1, down arrow, 3, right arrow, enter, is negative 1 and 1/3, plus 1, should equal 0. So let's plug all that in and see if it works. Fraction button, 1 over 3, right arrow, minus 1, fraction, oh no. I believe this would be UND to put in 1. Oops, let me do it over here. 1 1/3, yeah. 1, right arrow, and you can keep going with the right arrow until you're done. Plus 1, yeah, it does equal 0. So that's where calculators really come in handy for problems like this if you do have to check your answer. All right, please use them as you're doing your work. Okay. Same thing, no GCF, so we're going to think about factors of 7 and factors of 8. Factors of 7 are just 1 and 7. Factors of 8 are 1 and 8, and 2 and 4. Okay? So let's try some combinations. X and 7x is pretty solid. If we did 2 and 4, what would that be? 14x and 4x. That's not it. So let's switch them. This is 28x. This is 2x. That's not it either. So let's go to 1 and 8. This is 7x. This is 8x. And we want 1. So this is probably going to be it. 8 minus 7 is positive 1. So if this was positive and this was negative, that would work. So that means the positive would go here and the negative would go there. And negative 1 times 8 is still the negative 8 that we want. So that's good for the factoring. And then it's just a matter of solving. So same kind of thing as before. Let me do this down here. X minus 1 is equal to 0. And 7x plus 8 is equal to 0. So again, solve it the same way you normally would. X is 1. Minus 8. 7x is equal to negative 8. Divide by 7. And again, you get a fraction. I would also say if you get something like this, in general, leave your answers as fractions. And I would say leave it as an improper fraction too. All right? And again, for time's sake, I think we're going to hold off on checking your answer. So this one looks pretty similar. All right, one more and then I think we'll call it a day. As I keep saying, you always have to worry about taking out a GCF first. So 21, 90, and 24 are all divisible by 3. It gets you 7, 30, and 8. Okay? There's no variable component, so your GCF is just 3. 7x squared plus 30x plus 8. So factors of 7 and 8 are going to be exactly the same as what we did before. 1 and 7, 1 and 8, 2 and 4. But we want to get 30 this time. Okay? So we'll go in the same order because I don't remember what the pairs were. We have x and 7x, 2 and 4. This is 14x. This is 4x. That's not going to get 30. If we switch them, this is 28x, this is 2x, and that would get us positive 30 if they were both positive, which means these signs would both have to be positive. 4 times 2 is positive 8. That's good. Don't forget the GCF equals 0. And then we're going to solve it. As we saw before, the 3 really only changed how we factored. All right? Setting 3 equals 0 or equal to 0 is not possible. So that's not going to get us anywhere. So we're just going to do x plus 4 equals 0 and 7x plus 2 equals 0. So minus 4, x is negative 4, minus 2, 7x is equal to negative 2. Divide by 7. X is equal to negative 2 over 7. And there you go. And again, check your answer. if the question says, or if you have time. But considering this is almost half an hour, might be the longest video that we've had up to this point, we're gonna hold off on that. All right. But that's basically solving by factoring. We are gonna do more with it tomorrow. But yeah, if you guys have any questions, you're more than welcome to use the question forum, Google Hangouts, the chat. It hasn't really been used. None of those things haven't really been used that much for any purposeful questions, so try using those. And yeah, I think that's it for now. Talk to you guys soon.